Welcome after the break. Now I'm with Michael Yarichuk, who is head of backend engineering and Bindesi, and Michael will show us how to deal with spaghetti monster using ECS pattern. And as always, you can post a question to the Michael on the chat and not hesitate and don't wait until the end of presentation. So Michael, the floor is yours.
So hi everyone, and my name is Michael, and first of all, thanks for joining my session. And let's start. So I think worth mentioning that I love writing code, and I do it a lot. And during my day job, I write lots of enterprise code because that's what I do. That's what I get paid. But my passion for a while now is game development. And today we will talk about entity component system design pattern. And I would like to try and convince you that this pattern is awesome and very useful, and not only very useful, but it is useful also in enterprise development, not only in game dev. And we will get back to ECS pattern a bit later, but now we will just first we'll discuss about enterprise development, what kind of things can go wrong, how spaghetti monsters can get born out of pretty much following recommended use cases and recommended best practices, right? Sooner or later, eventually, some sort of spaghetti monster will become out of any project, any enterprise project. And then we will take a look at how entity component system can help simplify and make your lives writing code easier, right? So let's take a look at how spaghetti monsters get born. So we will be looking at certain aspects of an e-commerce platform, which is, I suppose, pretty typical enterprise use case, well-known problem domain. Think about services like Amazon or Steam, which have, shopping cart and several types of products, searches, stuff like that. So nothing out of the ordinary, right? So you would typically model your product something like this. So you would do an abstract class, right? In your data model, you would have an abstract class, and then you would where you would do some common properties, right? Then maybe you have physical products like, if we talk about a service like Steam, maybe you have some, discs and maybe merchandise for the games, and then you have the downloadable part of the product where you get links and you download, right? Because that's what Steam usually does. And then maybe you have a subscription for, I don't know, say season pass or something like that, or maybe you have subscription if you're talking about Amazon, Amazon Prime, your videos and whatnot, right? So nothing, best practice, right? Common sense, object-oriented, inheritance, basics, right? So then we want to implement a shopping cart, and let's take a look at how something like this might work for an e-commerce website. So we'll take a look at two aspects. We'll see what needs to happen basically when you want to fetch data for the UI and show what kind of items you have in your shopping cart, right? And then what might happen if you forward and press pay and you forward your order items to some payment system. So essentially, fetching data and formatting it for the UI might seem trivial, right? You just take into account certain specific properties per per type of the product, right? And you do some whatever formatting and transformation for your data in order to show it as the business requirements tell you, right? The problem here that you might and probably will need to show different UI items and elements per product type, right? So a downloadable product, you might see there some sort of a link maybe, and physical product, you might see some, I don't know, preview for the products you get, or maybe some link to a list of those products that you get sent, right? The problem is shopping carts needs to, a shopping cart controller will need to know about each product type, right? This means for each product subclass, and then the problem begins, because now you have tight coupling between your business logic, your data model, and when you do changes, you do maintenance, though because of the tight coupling, your changes ripple out in your system. You create ripples, and each new product type you add will complicate the logic even more, right? And that's just one controller, and large systems have, I don't know, at least dozens of controllers, right? Because systems usually are not that simple. For enterprise systems are not that simple, right? Now, if we take a look at more, for example, more functionality, we will see another problem that first of all, you will need to do differentiation between types of products for payment, maybe different taxes for different types of product. Maybe there is some certain business rules for subscriptions. Maybe email needs to be sent with subscription details for certain product, right? Think about I don't know, Patreon subscriptions for comic book artists that produce updates, for example, right? So essentially, you will have two things. First, business logic will be tightly coupled in more ways, as we said before, but also you will need to do conditional in addition to business logic. You need to do some conditional logic in many parts of the system, right? And over time, this will cause another problem with maintenance. That's a bit problematic, I would say. I think you would agree. Now, what if, because most of the time, enterprise systems grow and evolve and become more complex, right? What if we, for example, if we take a look at Steam service, right? What if we want to have a downloadable and physical product at the same time, right? For example, you have a premium version of a game that is downloadable, sure, but it also has a figurine, maybe some physical merchandise, I don't know, art books and stuff like that, right? So now we have a choice, right? We will need either create permutations per product type, right? So we copy paste, because even if we program in a language that allows multiple inheritance, we don't really want to do multiple inheritance. There is a reason why most programming languages do not have multiple inheritance. So essentially, we'll need to create either permutations of projects. So we will create a inheritance tree that is wide, or we will need to do a deep inheritance hierarchy, which both of those will complicate things further, because both of those will require even more conditions and more bugs potentially, and more testing to be created. More tests mean more maintenance. Overall, over time, such things will tend to accumulate, such changes, right? So I would say that's a problem too, potentially, right? Of course, if you follow best practices and you adhere to clean code practice and stuff like that, there are ways of mitigating this kind of issues. But still, it complicates things, and we as developers always want to have things as easy as possible, right? Now, let's take a look at another aspect of the system. How would we implement promotions and discounts and stuff like that, right? So a large e-commerce service would likely have all sorts of promotions, maybe seasonal promotions like Black Friday, right? We would have brand promotions, so some brand pays you to promote their stuff. Maybe you will have some, I don't know, if we talk about Steam, RPG game week, where you do discounts per category of some product, right? So typically, you would do something like this. You will create abstract promotion class, right? You will make product aware of such thing, and as a proxy, you will make any business logic aware, the same shopping cart controller, right, of this thing. And then you will need to do even more conditional logic to take into account when you send things to payment system, for example, to apply price. Maybe this will not be in the shopping cart controller, maybe this will be in some place else, but still the problem will remain. There will be tight coupling between the promotion, the discount part, and the product part, and the business logic that handles products, maybe ordering, maybe shipping. For example, Amazon sometimes has discounts on not only what product, but for shipping, for example. So certain products have free shipping, for example, or Amazon Prime has also this kind of discounts for shipping. So this kind of thing will create some more problems and eventually complicate code and make the maintenance more expensive, right? Now, let's take a look at how can we make our lives easier. So let's take a look first at what actually is this design pattern that we will be discussing, right? So itty-bitty part of history, as they say. The idea, this design pattern originates in game development, and you might have seen if you played around with gaming engines like Unity, for example, you might have seen this design pattern utilized throughout the engine. Overall, not every game uses this design pattern, but enough of them use. So in game dev, this pattern is pretty widespread and well known. In other kinds of development, like enterprise, not necessarily so. And first, this pattern was invented to make developer lives easier, to make the code more scalable, flexible, and of course maintainable. And also it provides a very nice optimization. We will see in a minute what exactly do I mean by optimization. Now, the idea behind this system is the following. You have entities, your business objects, right? Your business entities will be called entities, right? Very convenient, but those entities are essentially IDs. They mean nothing by themselves, right? They have semantic meaning from the perspective of business logic, but from the perspective of the design pattern, they mean nothing. what actually means something are the components, which will be essentially DTOs, bunch of objects that contain only data, not functions, not methods and such. And the idea is that you can attach or remove from each entity any number of components. So entity essentially gets its data added or removed its properties at runtime, right? If I'm not mistaken, this kind of pattern is sometimes called mixing. So it is kind of a mixing, I think. Now, it's not the pattern called entity component system. So the system part, systems are essentially self-contained business logic, self-contained business logic modules, right? And best practice is to have them self-contained without any dependencies. And essentially, they don't care about entities. They work only on components or combination of components, right? In quote-unquote classic ECS implementations, systems cannot even access entities. They can access only the components they are supposed to process, right? Some implementations, like default ECS, that's the library I'm using for this talk. We will take a look at a couple of code examples for this library. So it does allow you access to entities as well, but essentially systems are not supposed to deal with entities directly, right? And why have I said that it is an optimization? If you remember that screenshot from top-down space shooter game, games like that have lots of things flying around, lots of objects that needs to be taken into account. While it's perfectly reasonable to have an array of bullets, of missiles, of spaceships, of enemies and stuff like that, when you have large enough objects and their arrays, it's not exactly cache friendly. And since entity component system implementations typically have, not typically, there should have, that's how they're supposed to work. They have arrays of components of the same type that are sequential in memory. Iterating system that is processing components of the same type essentially uses data locality to improve its performance. And just in case you have never tried to see what is the performance benefit of data locality, consider two-dimensional arrays and two possible iteration over such an array: row, then column, and column, and then row, right? For I and for j, or the reverse option. And according to my experiments, so for this kind of iteration, row then column, column then row, it's order of magnitude faster to the type of iteration that uses data locality. So this is a very big, that can be very big performance optimization for systems needed. Not all systems. Games usually need performance, but not all enterprise systems require extreme performance. But other benefits, as we will see in a second, do have their uses. What kind of benefits am I talking about? Essentially, ECS, in addition to data locality, it allows pretty much separation of concerns, simply because it separates data, which is components, right, from the behavior, business logic, which means the systems. And it is much easier to reason about the code and maintain it because you have a specific behavior isolated into a certain system, right? And also, it allows to avoid deep inheritance or inheritance permutations, because now you have dynamic components that can be attached or removed from your business entities, which removes the need to create inheritance trees whatsoever, right? Because you can mix and match components the way you want it. And thus, it allows you the ability to add components later on and add systems that deal with them that are not related to other systems that were existed. This allows extensibility of the code because the new system, if the ECS pattern implemented as best practice shows, which means systems are self-sufficient, this means that any new extensions to codebase will not affect other parts of code. And I think you will agree with me, this is a good thing. Now, let's see how we will deal with shopping cart if we implement ECS pattern for that use case. So we'll have now a product entity, right? And we will separate each type of each type of product into a component, right? But also we'll have some more components that will add information to our product. For example, if a user enters shipping information for the order, then we will just add for each product in the order, product entity, we'll add shipping info component, because why not, right? Maybe those components will be shipped off, those products will be shipped off via several companies, for example. So you don't have to have shipping info per order. You might also attach shipping info per several entities, right? Now, the way most entity component systems work, you don't have to have a new instance of component per entity. Typically, entities, you can share certain instances of certain components per groups of entities. So essentially, if you have, let's say, 10 products in an order, you can share one instance of shipping info component in such a case with all of the products. So that's a good thing. And if that's a concern, so this will also allow some, and ECS in such cases allows very nice memory usage optimization, right? Because you don't, certain aspects of the system, their instances can be reused and attached to several entities, right? So that's, in my opinion, also a good thing. Now, fetching for the UI will be, this chart, this UML seems a bit involved, but it's actually very simple. Shopping controller will fetch the relevant entities, right? But not necessarily, but conceptually it will fetch the relevant entities. And it will send them to each system per component, per component combination. For example, for each physical system, there will be physical UI formatting system, right? But if you have physical and downloadable product, right? So you will have separate system that might need to take into account the two components that are attached to certain product, right? And in this case, you will have isolated logic per product type, and the ECS system itself will handle the conditional logic that is inherent to this kind of interactions. Why? Because typically implementations of ECS libraries, they allow systems to query, quote unquote, for entities that have certain component combination. We will see when we will see the code samples, we will see exactly how it looks. It is simpler than you might think it is, according to my words, but still. Now, payment for products will be also a bit simpler than that. Essentially, shopping cart will send all its entities to order processing system, which will apply business logic for payment, for order status, and add relevant components to the products, right? And then payment system will pick it up, because payment system will detect that order status component, payment info component exists on certain entity. This means that those are products that needs to be shipped somewhere, and it will add them to shipping queue, produce domain level event to signal other parts of the system that yeah, there is some products that need to be added to the shipping queue, stuff like that. So I think you can imagine how such things should work, right? Once the payment clears, of course, right, for the products. So nothing too complex here, I think. And about promotions, it will be even simpler than the products and the ordering. So now we'll have simply have components for each type of discount, right? And you will have promotion system that will take a look at products that are marked as that they need to be processed before they get sent to payment system, right? And it will apply relevant components with discount percentages and whatnot to the product, right? And then payment system, or maybe another system that, or either payment system will take into account those components, or you might have another system that will adjust the cost data in the product, in the component of the product entity that has the final price according to those components. So the rest of the logic will be can have several possibilities, possible implementation depending on the requirements and the exact business flow, right? The idea here that instead of tightly coupling, what I want to show here, instead of tightly coupling promotions to product and to shopping cart and such, this logic of applying discounts will be separated and isolated into a separate system that will, a separate module, let's call it like that, that will actually apply this kind of logic to products. Okay, so let's see some code. Nothing too complicated. Default ECS is an open source library in .NET. It's not the most famous or the one that has most stars, but personally I like it because of its simplicity and its adherence to .NET best practices and its focus on performance. As you can see, for example, this is a code of a system. What you see here is code of a system that, for example, shopping cart might use to format a downloadable products for UI, for shopping cart UI, right? So what I like, for example, you can see that fetching a component from an entity gives you a ref value, and overall, this library, I like it because it focuses on performance, and I like performance. What can I say? Now, the interesting part here is to see that in the constructor, we say world, which is in the language of this library is essentially an entity set, right? You can have multiple worlds, right? So they get entities that have certain components, and we can add, for example, with downloadable component dot with a physical component, right? So then the system will filter and act only on components that have act only on entities that have only two components. Now it will have or work only on entities that have one component. Now, due to how ECS pattern works, the entities might have more components. So in theory, conditional logic is possible within a system. So That's also a possibility. But ideal systems do not have conditional logic. But we live in we don't live in a perfect world, so things can happen, right? Now, dealing with the entities and using the system is also simple. We create a new world, which is a set of entities, pretty much. We create an entity in the world. We can set, and you can see that setting a component is also easy, right? And then we take the system and execute update, which essentially goes over all of the entities that contained in the world, which is an entity set, right? And it filters for the entities that, according to the rule that you have seen in the previous slide, and does whatever business logic is programmed in that system, right? So another thing that I like in this pattern, that it is not a black magic. It does not do stuff that are not supposed to. It's tricky to implement, but the idea is not complex. It's just a bit different than what is usually done with OOP and design patterns that are based on OOP. Right. So, in conclusion, object-oriented programming and enterprise programming, it has many possible issues that can arise from it. Tight coupling and problems with over-engineering, and sometimes they yield maintainability issues, and of course spaghetti monsters get born out of that. And ECS might help you, or may help you to be more exact, in certain cases, but it's important to remember that it's not a silver bullet. It is a design pattern that is different than what people are used to. So there may be some learning curve to properly apply and design your system to use ECS. It does not necessarily have to replace object-oriented code or things like MVP or MVC patterns. Usually, I've seen systems that were complemented by such a pattern, and ECS can help create more modular and maintainable code that is open for extension, as they say. Yeah, and spaghetti monsters are not that horrible as some people might think, but still maybe ECS will help you deal with your spaghetti monsters of your code. So thanks for listening and watching, and I would love to hear your questions.
Okay. Michael, thank you very much for your presentation, and I will look on our chat if we have any question, and I can't see any questions, so it's time to finish this session, I believe. I check once again chat. No, nothing has appeared. So thank you very much, Michael, for your presentation. Thank you very much for your participation in this session. And of course, as always, you can rate this presentation using stars under the video player. Your feedback is very important for us. So thank you very much, and see you on the next talk.